Welcome, class. In this video, we will go over section 8.3, the Review for Mastery worksheets. This lesson covers graphing quadratic functions by first finding the axis of symmetry and then plugging the axis of symmetry into the function to get the vertex. And from there, we'll find the y-intercept and a couple additional points. Just to look at the example here, it says y equals x squared plus 6x plus 8. The first step was finding the axis of symmetry using the equation x equals negative b over 2a. The second step is plugging in this value. In step 1, they got an x-axis value of negative 3. They then plugged the negative 3 back in to wherever the x was in the original function. And we can see the work right here. And they got a y value of negative 1. So the vertex is negative 3, negative 1. We also have the axis of symmetry. So they first graph the axis of symmetry. You can see it, the dotted line right here. And the vertex was negative 3, negative 1. This graph is a positive x squared graph, so it will open upwards. So it will definitely be opening upwards. They next found the y-intercept by plugging in 0 for x. See, in step 3, we find the y-intercept by plugging in 0 for x. And they got 8. So 0, 8 is the y-intercept. And here they just found a couple other points. See, they plugged in negative 2 for x, and then y equals 0. Then we plugged in x equals negative 1, and y equals 3. And you can see the points here. There's the vertex, the y-intercept. Here, let me change colors. Okay, here's the vertex, the y-intercept, and they found 2 additional points. And of course, we can make a mirror image across the axis here. Because if this is 2 spaces across, then we go 2 spaces. Here's another dot. This is 1, 2, 3 across. We go 1, 2, 3 units. And of course, if we connect the points, we now have a parabola. So that is the concept for this lesson. Let's take a look at number 1. X squared plus 4x minus 12. It says find and graph the axis of symmetry. Well, the axis of symmetry is going to be x equals negative b over 2a. We'll do x equals negative b over 2a. We have to first identify the values. X squared, a equals 1, plus 4x, so b is 4. And c, of course, here is negative 12. Now, there's another video that goes over this in more detail, but since this is the second video of the same lesson, we're just going a little bit faster. So x equals negative b over 2a. So it's negative 4 over 2 times 1, which is negative 2. Then now we will plug in negative 2 and find the y-coordinate. We'll plug negative 2 into here, here. So we get negative 2 squared plus 4 times negative 2 minus 12. We get a 4 minus 8 minus 12. We combine those terms, we get a negative 16. So the vertex is negative 2, negative 16. Now to graph the y-intercept, what do we plug in for x? It says to find the y-intercept. What do we plug in for x? Well, we always plug in 0. If we plug 0, again where the x's are, we will get 0 squared plus 4 times 0 minus 12. So 0, negative 12. Now let's go ahead and start graphing a little bit just to see what this should look like. We'll first graph the axis of symmetry, x equals negative 2. We can then graph the vertex, which would be negative 2, negative 16. So there it is. Now this is a positive x squared graph. So this graph will be opening upward because it's a positive x squared. Now we know the y-intercept is 0, negative 12. And because there's a line of axis of symmetry, it's 2 spaces away, we can go 2 in the other direction. So we already have 3 points now. So we really could just find one more point. Well, let's just find 2 more. So we'll find 2 more points. We'll plug in points close to the axis of symmetry. Let's see. Well, actually, I'll plug in 1's a nice number. If we plug in 1 back into the original function of x squared plus 4x minus 12, we will get 1 squared plus 4 times 1 minus 12. 1 plus 4 is 5. 5 minus 12 is minus 7. And we'll plug in 2. 2 squared plus 4 times 2 minus 12. 2 squared is 4. 4 plus 8 is 12. 12 minus 12 is 0. So we have 0. Now, so we have 1, negative 7, and 2, 0. Again, we can just do mirror images. 1, 2, 3 spaces. And this is 4 spaces, so 1, 2, 3, 4. And we now have our parabola. Oh, here we go. And here's our parabola. Now let's look at the other worksheet here, or the continuation of the mastery. Now we're going to be working on some application. We're going to have a word problem. It says here the height of a soccer ball kicked in the air can be modeled by a negative 16t squared plus 32t. Pay attention to this negative sign. This means the parabola will be opening down. And most things that travel in anywhere where there's gravity is going to follow this parabola pattern, where it goes up and it comes back down. This is very common, and this is due to gravity, because of gravity. Now it says the height is modeled as a function of time. See the t here, f of t, as a function of time. Minus 16t squared plus 32t. This means whatever we plug in for t, we will find f of t. And f of t is simply the height. So we can find the height by just plugging in the time while the ball is up in the air or up until the moment it hits the ground. Now, this equation was actually graphed here for us. And it actually starts at time 0. And they found the axis of symmetry using x equals negative b over 2a. And it must have equaled 1. So it took 1 second for it to come up. If it takes 1 second for it to go up, it will take 1 second again for it to come back down. And there are some interesting patterns about parabolas. However fast the ball was launched coming up, it will be traveling back down at the exact same speed, not velocity because direction matters, but the same speed at the same height. So however fast the ball is traveling here is how fast the ball is going down at the same height. However fast the ball is going when it hits the 12-foot mark is how fast on its way down it's going down. So if it takes 1 second for it to go up, it will take 1 second for it to come back down. So if it takes 1 second to reach maximum height, in another second it'll be back to the ground. We know it spent 2 seconds in the air, as you can see on the note sheet. It spent 2 seconds in the air. The vertex here is 1, 16. Remember, x-axis here is time, and this is height. So at 1 second, it was at its highest point, which is 16 feet. Let's look here. Now, let's do one word problem together. Height in feet of a rocket launched straight up in the air can be modeled by the function f of t equals negative 16t squared plus 36t. Now, this problem is in English units. By English units, I mean in feet, not meters. This is why we see this negative 16. because this is related to the gravity. Objects fall at about 32 feet per second per second. And this negative 16 is because the actual gravity equation looks like this. It has this 1/2 gt squared. And if gravity is 32, negative 1/2 of 32 is negative 16. So that's where this negative 16 comes from. So it says find the time it takes for the rocket to reach maximum height. Okay, let's find the axis of symmetry for this parabola. X equals negative b over 2a. The b here is the 96, and of course the a value is the negative 16. So negative 96 over 2 times the a value, which is negative 16. Negative 96 over negative 32, which comes out to 3. It says find the time for number 6. Find the time it takes the rocket to reach the maximum height. We know it's going to take 3 seconds because that is the axis of symmetry. The axis of symmetry will give us the time. It's always going to be either the maximum or the minimum. In this case, x equals 3, so you can see right here, is at the maximum. This is a maximum because this is a downward facing parabola because of the minus 16t squared. Now it says find the rocket's maximum height for number 7. Well, we will plug 3 back in. 3 back into the equation, minus 16 times 3 squared plus 96 times 3. Minus 16 times 9 is minus 144 plus 96 times 3. Let's see, that's going to be 3. I believe it's going to be 288. Now, minus 144 plus 288 is a positive 144. The maximum height, of course, is here because the time was here. So 144 feet is the maximum height. And we can see it, of course, off the graph. Now, this was graphed just so that we can see that the equation and the parabola drawn, they both match up. So just so we can check our answers. Now, find how long the rocket was in the air. Well, if it takes 3 seconds to go from the ground up, then it takes another 3 seconds for it to come back down to the same height, which is at the bottom. So the total time in the air is 3 seconds up and 3 seconds down, which is 6 seconds. For almost all your word problems, when you have x here, it's almost always going to be the time. And y is usually either the height or it could be a distance. It just depends on what kind of problem that we're doing. In this case, of course, this was all height. And there we go. We just solved our first real-world quadratic word problem.